Hello, today I am going to share with you how to solve instrument output signal value based on the reverse acting linear equation that I have created in my previous video. Okay, let me draw a simple picture so that it will be easy to explain. Okay, let's say I have a pressure transmitter here. So this is my pressure transmitter. Okay, for example, this pressure transmitter is used to measure the process pressure inside the tank. And the process pressure range is 3 to 15 psi. And this pressure transmitter parameter has been configured as reverse acting. Means these three, which is a RV of the process range or the low range value of the process range, will be proportional to the maximum value of the output signal, while the 15 psi, which is the URV or upper range value or the maximum value, will be proportional to the minimum value of the output signal. What do I mean by this is instead of the output signal, instead of 4 to 20 milliampere, it will become like 20 to 4 milliampere. As for the direct acting instrument, the signal will be configured in such a way as 3 to 15 psi will corresponds to 4 to 20 milliamp. Okay, that means the 3 psi correspond to 4 milliamp, while the 15 psi will be corresponded to 20 milliamp. For a reverse acting instrument, it will be configured reverse way. For example, for 3 and 15 psi instrument, it will be configured as 20 to 4 milliamp, meaning 3 psi will correspond to 20 milliamp, while 15 psi will correspond to 4 milliamp. Okay, for today's video, we are referring to this reverse acting. Okay, and the equation that we use is a reverse acting linear equation. Okay, so let's say the instrument that measure the process pressure inside the tank, and it reads the value of maybe 12.7. Okay, 12.7 psi. Okay, so what is the corresponding milliamp signal here? Okay, we can replace or substitute the x with the corresponding value here. Let's say for this LRV, okay, we can treat this PSI either as a y value or x value. We also can treat this milliamp value as x or y. It's up to you. Let's say I treat this PSI pressure value as my y value. Okay, so this is the LV or the minimum value. So the y n or the minimum y will be equal to 3 psi, and the yx, the maximum x value, will be 15 psi. Okay, and the y1 value will be 12.7 psi. Okay, and we need to find out the x1 is milliamp signal. Okay, the xx maximum x will be 20 milliamp, and the xn is 4 milliamp. Okay, as you can see, for reverse acting, 3 psi is equal to 20. You can see 3 psi is equal to 20 milliamp, while 15 psi is almost equal to 4 milliamp. Okay, 15 psi is corresponds to 4 milliamp. Okay, so now we have the two equation we can use to find the corresponding milliamp signal given 12.7 psi pressure. So if we use the equation 1, yx equal to mxn plus c. So we need to find the m. What is the m, or the slope? Okay, yx minus yn. This is a yx 15. Okay, 15 minus yn 3 psi. Alright, divided by xn, which is this one, 4 minus xx 20 milliamp. So we will get, let me calculate first, minus 0.75 minus 0.75. So yx equal to minus 0.75 xn plus c. We need to find the c. So yx equal to 15 psi. So 15 equal to minus 0.75 xn equal to 4 milliamp. Okay, c equal to, let me calculate. Alright, so yx equal to minus 0.75 xn plus 18. This will be a new formula for equation 1. Okay, we can further rewrite the equation. Y1 equal to minus 0.75 x1 plus 18. Okay, this will be our new equation. So now we know that x1 we know that y1 equal to 12.7. So 12.7 minus 0.75 x1 plus 18. So x1 will be equal to, let me calculate, 7.07 ampere. Okay, 7.07 milliampere. Okay, this is using equation 1. If you want to use the equation 2, then it will be y1 m x1 minus xx plus yn. So the m is minus 0.75 x1 minus xx plus yn. So we can rewrite the equation minus 0.75 x1 minus xx is this one, 20. So 20 plus yn is this one, 3. So this one will be our new equation 2. Okay, so as we know, y1 is 12.7. It will be 12.7 psi equal to minus 0.75 x1 minus 20 plus 3. And then we can find out, the x1 value. So after calculation, the reading is about 7.07 milliampere. Okay, that's it. Thank you.